Hello, everybody. So I want to take you through just a very simple example of how we might use Avogadro's number to count atoms or molecules. And we're going to use the example of HgS. So HgS, Hg is the chemical symbol for mercury. S is sulfur. And these will combine in a 1-to-1 ratio to give us the mineral cinnabar. The cinnabar is HgS. So let's say we have 10 grams of cinnabar. We've got a mineral here. Make it quasi three-dimensional. That's about the best that I can do. So let's say that sample of cinnabar weighs 10 grams. Well, the power of the periodic chart and Avogadro's number is that we can use that weight to be able to count the number of molecules of cinnabar or the number of individual atoms of mercury or sulfur that are inside of that sample. And the way we do it is like this. We will start with the atomic weight of mercury. So mercury is a very heavy atom, very heavy element. It has an atomic weight of 200.59 grams per mole. Sulfur is a much lighter element. It has just a mere 32.065 grams per mole. Very light compared to mercury. So what about cinnabar, HgS? Well, that would be, we just have a 1-to-1 ratio of these. So we would just take the sum of those two things. So if we add those two together, we would get a number of 232.655 grams per mole. That's the molecular weight of hydrogen sulfide, or rather the molecular weight of cinnabar. So how many molecules of cinnabar would we have? Well, we started out with a sample that weighed 10 grams. And what we want to do is multiply that by a ratio where the grams will cancel out and we'll be left with moles on top. So we want something where grams will cancel and their moles are on top. Well, this is the number we're going to use here. Notice that it is inverted from what we want. We've got moles on the bottom and grams on top. I'll just extend this division line. 232.655 grams. So we'll write that here, 232.655 grams. And what's on the bottom? Well, nothing. Actually, there is a 1. Right? So if we don't have anything here, it's the same as writing a 1 in a fraction. We can write, for example, 2 is the same as 2 over 1. So if we do this multiplication, grams will cancel, we'll be left with moles, and this comes out to 0.043 moles. So we have 0.043 moles of cinnabar. Let's erase the chalkboard again. So 0.043 moles of what? Of HgS, because that's what we measured out 10 grams of. Now, to convert this to the actual number of molecules, we have to use Avogadro's number, which is 6.022 times 10 to the 23. And remember that Avogadro's number has no units at all. It's just a pure number. Like a dozen is equal to 12. Avogadro's number is this great big thing here, 10 to the 23. And we need that very big number because we're counting very, very, very small things. Atoms are tiny. So if we want to find out how many atoms we have or how many molecules, we'll simply take Avogadro's number and multiply it by the number of moles. And so when we do that, we have 6.022 times 10 to the 23 times 0.04, and that will give us 2.588 times 10 to the 22 molecules of HgS. HgS. So that's how many molecules of HgS we have in this 10-gram sample of Cinnabar. Now, what about the number of individual mercury and sulfur atoms? Every formula has one of these and one of these. So if there are 2 atoms per formula unit, then there are going to be basically twice the number. The total number of atoms will be twice this number. The total number of atoms in mercury sulfide will be 2.588 times 10 to the 22. Half of those will be mercury, half will be sulfur. Let's rephrase it a different way. If we have 2.588 times 10 to the 22 molecules of hydrogen sulfide, then that means we need the same number of mercury atoms and the same number of sulfur atoms. So for mercury, we've got 2.588 times 10 to the 22 atoms. And then for sulfur, we have the same amount, 2.588 times 10 to the 22 atoms of sulfur. And so if we have this many atoms of sulfur and this many atoms of mercury, then we can combine those two to make this many molecules of mercury sulfide.